I was asked to talk about Navy investment in technologies that could be used to study marine mammals. Now, to really give you a comprehensive review of that, you would have to go to an O&R program review or something like that, because the Navy is investing in all sorts of different technologies that can be used to study marine mammals. So I'm going to selfishly focus on the things that occur down in San Diego at the Navy lab where I work, and talk about some of the things that we have been involved with our colleagues at the Navy's Marine Mammal Program. Now, as you all know, the Navy has been concerned, as the community as a whole, I think, over the last 10 to 20 years about the potential for sound, particularly anthropogenic sound, to impact marine mammals. And there are a myriad of mechanisms by which sound could affect a marine mammal, ranging from injury to tissue, through physiological impacts to hearing, through behavioral responses, and in cases possibly where we don't see a behavioral response, still a physiological stress response that occurs in the animal. Now, the level of the impact can occur at all different levels, and as you can imagine, when you look at all the variables here and understand that each one of these things we want to look at is itself a multivariate problem, you understand how complex a situation it is and how much research is going to have to go into trying to understand just this issue, let alone all the other anthropogenic influences that exist in the world that can affect marine mammals. But today I want to talk specifically about some things that are affecting our studies of the impact of noise on marine mammals with respect to hearing, and then also whale behavior. And I'll start with the importance of hearing, because if we're talking about the impact that sound can have on any animal, the fundamental piece of information you need to know is, what does that animal hear? And remarkably, even though we've been studying cetaceans and pinnipeds for the better part of a century now, we have only made measurements of hearing sensitivity in about 30 of the species of marine mammals of the over 100 that exist. So for animals that make a living predominantly relying on sound, we know relatively little still about how they use sound, and even less about their auditory system itself. Now, for those animals that we do have information, we are also limited by the fact that most of those species' hearing sensitivities are represented by one or a handful of animals, which brings into question, are they truly representative of that species? As an example, there is one audiogram that exists for a monk seal that looks so different from all the other faucet seal audiograms that are in existence that people question whether or not that animal is truly representative of a monk seal. Nevertheless, because it's the only one that exists, it is the one that will probably be used in environmental compliance efforts until such time that we have better information. Well, one way around having to do behavioral audiometry, which is the classical way of doing things, and why it has limited our access to animals, because it does take time to train an animal to behaviorally respond to a hearing test, is to use auditory volt potentials. Now, an auditory volt potential is a voltage produced by the brain when the auditory system perceives sound. This is not new technology. It's been around for many decades, but it has not been applied readily to the field of marine mammalogy, because traditionally it has consisted of cobbling together all sorts of electrophysiological equipment, piecemealing it together, then having to do a bunch of offline processing, so you don't necessarily know if you're getting the answer you get until maybe days or weeks later. As an example, if you look here, this is the auditory volt potential system first fielded by Sam Ridgway in 1989. It took a truck, U-Haul truck, to get all the equipment there. So not something that is readily available and going to be used to assist us in getting this information. The technique itself, however, if you can get the equipment there, can get you rapidly the hearing sensitivity of a number of different species of marine mammals. Over the last seven years or so, Jim Finring, who is an employee of the Navy Marine Mammal Program, has been working to try and overcome two things. One, to develop a software system that allows researchers to go out and collect auditory volt potentials in marine mammals in a rapid fashion, something that allows you to analyze the data while you are collecting the information, so that by the time you are done collecting the information, you have your answer. However, we also need to deal with the issue of making it portable. Because if we have to take a U-Haul to every beach in the world to have an opportunity to work with an animal that potentially strands, or to SeaWorld, or any place, the captive facility that has animals, we're not going to get a lot done. Furthermore, this technique has the potential for a lot of confusion, and you can make mistakes fairly easily if you don't know what you're doing. So an added effort is to try and make a system like this as plug and play as possible. Excuse the terminology, but I'll say to dumb it down, so all you have to do is hook it up and push a couple buttons, and the rest is taken care of for you. If we can do all these things, then we have the potential for taking this technique and rapidly gaining information on marine mammals for which we have been slow to get information over the last 4 or 5 decades. Now, Jim has been very productive over the last 7 years, and he has developed a software package that he calls the Evoke Response Study Tool. It's very impressive in that it allows you to generate numerous types of acoustic stimuli. You do real-time analysis and display. It provides objective statistical analysis of the recordings of the Evoke responses, so it can tell you statistically whether or not that response is detected after signal is generated to the animal. It allows all sorts of post-processing as well. The success of this has really shown in the last couple of years, and not only the marine mammal community has shown interest in it, but it is now being used by researchers who work with primates in South America, to be used on fish, it's being used on turtles, I believe, although that may still be in the coming. So it has gotten a lot of attention from the community outside of the marine mammal community. But for the marine mammal community, we want to have it something like this. So over the last 1.5 years, Jim and I have been working to develop the plug-and-play Atlas. This system is set up ideally for testing the hearing of the darling-seed cetaceans. You can essentially hook the equipment up and hit go, and it does most of the work for you. Now, in about an hour's worth of training, we have been able to teach stranding network personnel how to operate the system and how to troubleshoot it if things do not look as they should. The system has also been completely portableized, if that's a word. If you compare the system on the left from 1989 to what the system consists of now, which is a ruggedized laptop computer and a biopotential amplifier that's in the Pelican case. So one person now can deploy to anywhere they need to go, given sufficient notice, and test a marine mammal. This makes it usable not only at captive facilities, but allows us to respond to stranding situations more effectively. Many of you may know that this technique has been used for about 10 years with stranded animals, but has generally been localized only to those areas where there are scientists who had the equipment to be able to do it. Paul Nocteville's lab in Hawaii, David Mann's lab in Florida, our lab in San Diego. Now that this system has become more available and the technique is becoming more available, we are seeing it rapidly being used in the collection of auditory vocal potentials, and we are rapidly acquiring more and more information on hearing sensitivities of marine mammals. The number of species lists that it's been used on has grown tremendously. Elephant seals, harbor seals, sea lions, stellar sea lions, Gervais beaked whale, beluga, bottlenose dolphin, harbor porpoises, 2 different types of lags, common dolphins, and the list is going to continue to keep growing. And it's going to maintain the potential, I hope, not only to get information on species that we don't have access to in facilities in this country or elsewhere, but also allow us to start collecting numbers of individuals so we can start asking questions about what is normal hearing in a marine mammal. Get away from the representation by one animal for a species, look at the variability in hearing sensitivity, and understand things such as when do these animals start to lose their hearing? How does age affect their hearing loss? How do drugs affect their hearing loss? There has been questions in the marine mammal veterinary community in stranding responses about the appropriate use of certain drugs. Some of them can be ototoxic and wipe out hearing. To really get at this, though, we need to put this system in the hands of first responders. Because as much as we, the people who have developed the system, would like to go out and respond to a stranding situation, it's not always easy to fly across the country at a moment's notice to do so. So in the last year, we worked with 2 stranding networks, the Marine Mammal Center in Northern California, and what was formerly the Cape Cod Stranding Network is now part of IFAW over in Cape Cod. We trained them up on a system. We built each of them a system. And they've had about a year now to work with the system and try to apply it. Now, we haven't had any data collections with the Marine Mammal Center. Part of this is simply because in Northern California, you just don't get many live stranded cetaceans, which is understandable. Now, the comparison group is Cape Cod, where they are inundated with live stranders. And in the last year, I'm very happy to say that they have taken the device and have tested 8 animals now in the last year. We had not previously had any information on Lagonorhynchus acuta. Now we have 4 samples for that, 3 of Delphinus delphi. Now, not all of these were successful. The harbor porpoise, for example, was so small that the suction cups wouldn't stick to it. These are practical things that we will just face and have to deal with. Nevertheless, when you figure that if you tried to do behavioral audiometry of these animals, not only would you have to care for them the entire time that you had them, but it would take you weeks to months probably to get the information that they acquired in less than 20 minutes. Just as an example, this is one of the Delphinus that they had done the work on, and the audiogram, which is shown on the left, is typically dolphin in nature, with a hearing range that runs from 10 kilohertz, which is the lowest we tested. That does go lower, obviously, but with good hearing up to 160 kilohertz as the roll-off extends. We expect, obviously, that we will probably see similar audiograms with a number of related species, although we also now know that with increasing size, we are starting to see different ranges of hearing, maybe an allometric scaling of hearing capability with size. So in conclusion, we think this system has a lot of potential for both the Navy and marine mammal researchers in general to acquire basic fundamental information on hearing capabilities of marine mammals. We've demonstrated that you can now take this system, and you don't need to be an expert with minimal training. You can apply it and get good quality data from stranded marine mammals. The challenges that we are currently facing are the 2 at the bottom. As always, with new technologies, you have issues with development and distribution. These instruments are not built by a company. They are built by myself and Jim Finneran, and it takes a considerable amount of time to put one together. So although we have people from around the country who have asked for some, it's not as if we can just pack it up and send it to them. The other issue is one that I've talked to Terry Riles about, is we ideally like to see amongst the stranding network personnel that if we ever get to a position where a system is deployed with each of the major stranding networks, that there is a centralized repository where people will share this information, such that if stranding occurs on one part of the side of the country, they do a hearing test and they'd like to know what an audiogram for that animal looks like, they can look it up and tell. Does this animal have a hearing deficit at the time of stranding? There's also some intellectual property rights issues I was discussing with John earlier. We're trying to work through as well. Jim Finneran, this has been his development completely from the start. It's been a one-person show, and he's trying to figure out how he can maintain credit for it without it disappearing into the ether, which is understandable. One other thing I'd like to talk about is a current technology that's really just a kind of a pilot study that we've been working on at the Navy Marine Mammal Program, is how to better study whale behavior. Now, there's a lot of questions about how sound or other anthropogenic sources might affect whale behavior. We need to know whether a disruption is significant. We need to know what a disruption is, or what is the normal behavior of the species to begin with. How do we tell if that behavior's been disrupted? And of course, we expect to see probably a lot of species and even individual variability in responses of animals to any given type of sound. So to achieve this, we need to have an effective means of tagging whales and keeping the tags on. Obviously, tagging offers us the best way right now to monitor behavior for extended periods of time. But for the elusive whales, and those I mean like the beaked whales and the smaller whales, not the large mysticetes, tagging efficiencies are relatively low relative to the number of sightings or the amount of effort that's spent looking for those whales. So one of the things we have entertained is the idea of using one of the Navy's assets, which is its sea lion system, which is a swimmer defense system. What the sea lion system does is it patrols areas for divers with potentially ill intent. And then the sea lion is trained, once it finds a diver, to return back to a boat where its handlers are. It is given what is essentially a large handcuff on a bite plate that is then tethered to the boat. And the sea lion swims out, finds a diver, swims up behind him, claps the handcuff on their leg, and then swims away. This leaves the diver with the fishing line attached to it that the boat then reels in. The animals are incredibly fast at doing this, and they're incredibly good at it. So we came up with the idea of why can't we train the sea lions to tag whales? We know that they do this well, so let's see if we can get them to increase our efficiency. The nice thing about it, hopefully, would be that one, you are not limited by sea state. The animals that you want to tag, if they dive, the sea lions can pursue them, as opposed to current tagging methods where you have to wait for the animals to be at the surface. Furthermore, sea lions care less about the sea state than most humans do. We're more comfortable out there in those types of conditions. We just did a pilot study just to see if we could get an animal to tag a dolphin. A little bit of a video here. Understand that this is an unfunded effort, but we're trying to convince people it might be worth investing in. The animal that is working here, the sea lion you will see, is an old sea lion. He's retired, so to speak. He has poor vision, yet we were still able to train him to do this behavior, which gives us a lot of confidence for working with a younger animal. So that's our hope that if this is something that once the tag just lit off at the end. We didn't put a lot of investment in the tag. We were investing in the behavior of the animals. We hope that we can get people interested in this technology for the future, because we think, particularly in the Southern California region, where the Native Marine Mammal Program is located, it could serve to really increase the efficiency of tagging points on the animals when they perform study counts. We do have to acknowledge that the money for a lot of this, the AEP systems we built came both from the Navy and from NOAA Fisheries. Sarah was actually very instrumental in helping us get that together. And we need to acknowledge that the stranding personnel are doing a fantastic job. They've told me they've been out there at minus 18 degrees responding to strandings and collecting data, which is more than I would be willing to do. So, anyway, thank you.